Welcome back, everybody. Today we're going to talk about the law of cosines. In the last section with the law of sines, we explored what to do if we had what we called an oblique triangle. That is a triangle that has no right angles. And we said we can use the law of cosines when we had like angle A and we had side A across from it to get, let's say, either angle B or side B across from it. Let's say. However, what if we had an oblique triangle where we had side A, B, C, but we had no angle? Or we had an oblique triangle where we had an angle C, but the only information we had were sides A and B. If we didn't have a side and an angle across from it, we couldn't use the law of sines right away. We would have to use the law of cosines. The law of cosines is a squared equals b squared plus c squared minus 2bc cosine of angle A. And remember, the angles are the capital letters and the sides are the lowercase letters. Now, depending on what information you have or what information you're looking for, the same formula could take different forms. So let's say I'm looking for side B. I would use b squared equals c squared plus a squared minus 2ac cosine of angle B. Or let's say I'm looking for c squared, or c. I can do a squared plus b squared minus 2ab cosine of c. So here are they're basically three different versions of the same formula, but you're going to use the one that you need depending on A, the information you're given, or B, what you're looking for. So very often we'll use the law of cosines to get the angle or side that will allow us to use the law of sines afterwards. The law of sines is most definitely the more user-friendly concept. However, in my opinion, the law of cosines is the far more useful concept. Let's start with a fairly straightforward example. I'll just give you a triangle. All right. If I say solve for side B, given side A equals 5 and side C equals 8 and angle B equals 77 degrees. Now again, your angle is not on the unit circle, so eventually we're going to have to use a calculator. But I'm always in favor of doing as much algebra as you can before you resort to the calculator. So let's start by basically picking the right formula. If we're looking for side B, I probably want to use this one, right? So we're going to use b squared equals a squared plus c squared minus 2ac cosine of b. All right, now let's take a moment to start putting in what we know into the formula. All right. And I got 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 77 degrees. Now we knew we need to use the law of cosines. However, I do want to draw this out very quickly to illustrate why we need the law of cosines. I probably should have done this before I started the formula. But this is just instruction. And angle B is 77 degrees. And this is side B. So it doesn't matter which one you call side A and which one you call side C, but we definitely don't have an angle and a side across from it, which is why we need to use the law of cosines. All right, so from here, why don't you take a moment, do 5 squared, 8 squared, multiply 2 times 5 times 8, and we'll see where we're at. Okay, hopefully you paused it. And we got 5 squared, I got 25 plus 64 minus 2 times 5 times 2 is 80 cosine 77 degrees. All right, at this point, why don't you use a calculator to solve the rest. All right, well, I got b squared equals, that's 89 minus 80 cosine 77 degrees. And so when I did that to finish off, I got b squared equals 71.00. And when you do the square root of your answer, I got b equals 8.4 about. So there's, I got side B. And again, no one would reasonably expect you to not use your calculator to get the square root of 71. All right, so let's try one more. This time we'll look for an angle. And the reason I want to try one more, look for an angle, is we just have a little bit of different algebra. So I'm going to give you a formula. A squared equals b squared plus c squared minus 2bc cosine of A. Now let's say we're looking for angle A, right? Well, I don't want to, if I don't have to, put it in a formula where I'm saying it equals side A. I mean, I can, but what if I could manipulate this formula using algebra to have the cosine of A equal something? Probably would be a little bit more of a user-friendly formula. So why don't you pause the video, take a moment, see if you could take that formula and manipulate it so we have cosine of A equals. All right, so it is just some algebra, things like subtracting b squared, subtracting c squared, dividing by 2bc, or negative 2bc as a matter of fact. But you should have gotten b squared plus c squared minus a squared all over 2bc. And now I could give you an example saying like a triangle has side A equals 90, side B equals 70, side C equals 40. And I could say approximate angle A to the nearest degree. Now, when I say approximate angle A to the nearest degree, basically I'm telling you to round to the ones place, round to the whole number. All right, so now let's do this more in order. The first thing we're going to do is draw out the triangle, because if we could use the law of sines, remember we said that would be best. It would probably be a little bit easier. But I got side A is 90, right? And then I'll use this as side B, 70, and this is side C, 40. Remember, we're going around in a circle. There's angle A. So I have a side, side, side situation, and I have no angle. If I have no angle, I simply can't use the law of sines. So I have to use the law of cosines. So let's start filling in this formula with the information that we have. All right, so I'm going to scroll up for a little bit more space. I'm going to say the cosine of A equals 70 squared plus 40 squared minus 90 squared over 2 times 70 times 40. And I'm going to ask you to, well, here you're going to have to use a calculator to finish. Typically in my classes, I have an expectation that my students will know their squares up to 20 or 25. But beyond that, would not be a question that I would ask necessarily. So let's use a calculator to finish. Pause the video, take a moment, and I'll see you guys on the back end. All right, hopefully you put everything in the calculator right. I got -2/7. So I have the cosine of A equals -2/7, which means in the calculator you put cosine to the -1, the arc cosine of -2/7, and I got 107 degrees. Now again, you need a calculator to finish this particular problem off. If your class does not allow a calculator, expect your instructor to make sure that the problems are non-calculator friendly. All right. So one of the best parts of the law of cosines is it can be used for a lot of different applications. So here's just one in particular that I like more than most. A surveyor needs to find the length of a pond, but does so indirectly. And this is very common for surveying because land isn't necessarily level, and it's not necessarily feasible to simply take a tape measure and stretch it across a pond. She selects point A on one side of the pond and measures the distances to points B and C at opposite ends of the pond. And they happen to be 537 and 823 yards respectively. The measure of angle BAC is 130 degrees. How long is the pond? Now, in order to get a good visual of this, the first thing I would do is draw a picture. So we need to make a pond. So here, I'll make a pond. Remember, your pond isn't necessarily a perfect circle, but if you made it a perfect circle, it wouldn't necessarily matter. And so here is your point, and we're going to opposite ends of the pond because basically we could get the width of the pond by creating a triangle. So this angle in here is 130 degrees, and distance to one of the points was 537. The distance to the other point was 823. All right, and really what we're looking for, I'll call it side C. So I could say like C squared equals A squared plus B squared minus 2AB cosine C. And what I'd like you to do now is we're going to pause the video, take a moment to just insert the different numbers into the formula. These are large numbers. It's going to readily apparent that you will need, this is a calculator type problem. Again, if your class does not allow calculators, you should trust in your professor to make sure that he gives you a non-calculator friendly question. But insert the numbers in, and I'll see you on the back end. All right, so hopefully you inserted the numbers. I got C squared equals 537 squared plus 823 squared minus 2 times 537 7 times 823 cosine of 130 degrees. All right, at this point, it is unreasonable to expect 537 squared. So let's use a calculator to finish. Pause the video, and I'll give you the answer on the back end. All right, so the answer I got was C equals 1,238.5, and I believe the label was yards. Let's take a look. See, yards. All right, it is important in these word problems to make sure that you don't just get the number. It's not, getting the number is part of what you need. The other part is relating it to the real world situation that the problem gives you. So this label is important, and I know that if I'm grading your paper, you will lose points if that label is not there. All right, so there's one more thing in this section, and it is Heron's formula. Heron's formula gives you area of an oblique triangle, right? We all know that area could be 1/2 base times height, but it also goes to show that in an oblique triangle, you won't necessarily have the height of your triangle, or it won't necessarily be so easy to get. Heron's formula is an option. So Heron's formula is A equals the square root of S times S minus A, S minus B, S minus C, where S equals 1/2 the perimeter, which is A plus B plus C. All right, so I'm going to give just one question because, you know, they're pretty much all the same. All right, so if I said a triangle has sides A equals 125 meters, or I'll say a triangle field. All right, we'll call that, we'll say a triangle field. That way we relate it to something real. There we go. A triangle field. Has sides of 125 meters. B equals 160 meters. And C equals 225 meters. And the question is, find the area of the field. All right. So we don't necessarily know if this is a right triangle or not. So Heron's formula is an option. So we start out by getting S. S equals 1/2 of 125 plus 160 plus 225, excuse me. So why don't you add those up, divide by 2, and I'll give you the answer on the back end. All right, hopefully you added them up, divide by 2. I got 255. I personally also like to do a lot of my math before I just plug into the formula. So I need numbers like S minus A, S minus B, S minus C. So that would be 255 minus 125, 255 minus 160, and 255 minus 225, excuse me. All right, so why don't you pause the video here? Get me what all three of those equal. All right, hopefully you paused the video and got what they equal. I got 130, 95, and 30. And now we can plug all those numbers into our formula. So I got A equals the square root of S, which is 255, times S minus A, times S minus B, times S minus C. All right, so let's do the calculation, and I'll give you the answer on the back end. All right, so if you did the calculation correctly, you should have gotten 9,720 meters squared, which would be your area. Remember, area is always square units. And there's your answer. All right, thank you guys for listening. There's a lot more practice ahead, but I hope you got a good introduction to the law of cosines.